Welcome to my Crane Arm Design Challenge podcast, where I, Liam Roulston, and my partner, Chloe Toe, will explain and reflect on our crane design. The goal of this activity was to learn better ways to combat and better understand forces. The forces to combat were gravity, which worked in coordination with the bowling ball to compress and increase the tension of our truss pulling down. If we had gotten to the live load test, the torque resistance would have been tested with the sand. Our project was 67.3 ounces with dimensions of 10 inches by 6.125 inches by 2 inches. We employed the flat truss system because it was the easiest way to support all of that weight. We thought it had a fighting chance to survive both loads, but there were points in the structure that were thinner and didn't fit together perfectly, but that's just the way the cookie crumbles. If we had more time, we would have reprinted these pieces to ensure a perfect fit. This project has taught me to be more thorough in measurements and less idle when I find out there's an issue with my project. Going forward, I hope that I can be more precise and thoughtful with my work. I thought it was really cool to see all of our projects get destroyed, and I'm done talking, so let's go to Chloe for the play-by-play.
Sadly, our project did not pass the dead load test. Here you can see it is stable and upright with no load. Then you notice it gets crooked real quick when the bowling ball is relying on it all. Finally, it snaps right off the board because of poor bolt placement. Tragic, funny, but tragic. It did not work because of all the force that was displaced to the top of the back of the truss, but our bolt was in the middle, rather than where the force was being applied. If we had put the hole for the bolt in top third of the back of the truss, it would have at least passed the dead load. Also, we could have reprinted the sides of the truss to make them more stable, and actually 6 inches. Next semester, I would recommend to all students to be sure your project has no seams and keep in mind where the force is being directed to.